Hi everyone, and welcome to the next session on this breaker track. I'm happy to be joined here by Timo, Pagel and Stefan Fleckenstein, who are going to talk about their OWASP project today called Project DefectDojo. So they're going to tell you all about the project, which is an open source vulnerability management tool that streamlines testing. So good stuff. So I'm JP, I'll be your moderator for today's session. We're going to have roughly 20 minutes of talk and 10 minutes of Q&A. So make sure you use the Q&A function in the Hoover app to ask all your questions to the guys. And yeah, we'll answer them towards the end. So guys, take it away. I'm looking forward to hearing about this.
Thank you, Jenna. You should see my screen now. Correct.
So we can see you guys.
And the screen, right?
Not the screen yet.
I can see your screen.
Oh, well, as long as Stefan can, then yeah, we should be good to go.
All right. Thank you. Yes, Stefan and I would like to present OWASP DefectDojo today. First of all, who we are, then I give you an overview of the agenda. I'm Timo Pagel. I'm a cloud security freelancer. I'm living in Hamburg in Germany, and I love open source projects. That's why I present OWASP DefectDojo today, how I use it in my work. Stefan.
Yeah, I'm Stefan Fleckenstein. I'm head of cybersecurity at the company Wolf in Germany. And in my spare time, I'm one of the moderators of the DefectDojo project, which I joined like 1.5 years before. So purely a hobby for me, but a hobby that has something to do with my day job as well. Timo.
So here is the agenda for you. We will give you an introduction of what is a vulnerability management system. I will tell you my use cases. So why do I use DefectDojo? What are the tools I'm using to feed findings in DefectDojo? Then we will explain some features which are very important from our point of view. And then we will have a demo because this is a showcase, right? So we try to have most of the time as a demonstration of the tool itself. So why vulnerability management system? As we heard in the talk before, for example, there are Kubernetes security scanners or Docker security scanners, and you also have an application, for example, which you want to scan on different levels, for example, for known vulnerabilities or for vulnerabilities which you introduce in your code. And all these different scanners produce findings. And in case you already plan to have multiple tools you would like to use, it would be good to have one system to consolidate all the findings. That's why you need a vulnerability management system, and DefectDojo is, from my point of view, a very advanced one. You can see here on the documentation page that there are a lot of tools already integrated. You see, I can scroll like of endless. So you don't have a lot of work to import these different findings from the tools. DefectDojo, I have to say, is kind of a bit dumb. It's not generating these findings. It's just managing the findings. That is something sometimes is misunderstood. So DefectDojo is there to help you to manage the findings. That's why it's a vulnerability management system. It's not a scanning tool. So how is DefectDojo looking? DefectDojo has a structure. You have a product type where you can define, for example, that you have very important applications and not so critical applications, or you say you have internet-facing applications and non-internet-facing applications, or you divide it by stack, front-end and back-end applications. That depends on how you would like to use it. Then you have product. The product is a product which gets tested. How often it is corresponding to a GitHub repository, so one application. Then you have the manager, the engagement. So one product can have multiple engagements. I use these engagements to refer to the different tests. Then you have the test itself under it. Kind of right now I do a test, and in 5 minutes I do a test, and so so on. Each test can have multiple findings, and depending on how you scan, you have endpoints or not. So when you use a dynamic application security scanner like OWASP, you will have endpoints. In case you use known vulnerability scanning tool, a software composition analysis tool, then you will not have endpoints. So when you use DefectDojo like I do it in an automated way, a very important feature is the deduplication, because you scanned yesterday, then a developer analyzed the finding, and maybe the developer figured out this is a false positive, or there is no patch available. That's why I want to accept it for now. And in case the developer made these decisions, it's important that the notification is not there on the next day again. So that's when this deduplication comes into picture. Let us start with the top picture, with the picture on the top. You see the product, which has the engagement, which has a test, and then you see here there is a finding A. This is the original finding, and finding B. Then you, on the next day or after a minute, you perform another test. And then DefectDojo identifies, I had this finding in the test before, so I create a reference. That is a deduplication. It deduplicates the findings, says, hey, I saw this one here beforehand. When there is another finding which wasn't there beforehand, then this is a new active finding. And now we come to a more specific feature, which is deduplication on product level. That means that DefectDojo will look for the if the finding is somewhere in that product already, that you can see here on the right, you have another engagement, then a test, and then a finding. And when you do it on product, when you do it on engagement level, you see it on the bottom here, where you have the division line here. So DefectDojo only looks in the same engagement and not in other engagement for that finding. I use different tools. I use Secure Codebox and the cluster image scanner. Both are actually tools which orchestrate other scanning tools so that I can feed the results to DefectDojo. I very briefly explain these tools. So this is Secure Codebox, where you which you deploy in a Kubernetes cluster. And in the Kubernetes cluster, when you deploy a new service, the auto discovery recognize, hey, there is a new service deployed, so I create a scan for it, an OWASP instance for it. Then the OWASP instance will be configured and started to go against the Kubernetes service which has been deployed. You will identify findings, and these are getting uploaded to DefectDojo, and findings which are not handled are getting handled by sending out notifications, for example, via Slack or RocketChat. The cluster image scanner works a bit different. It's also deployed in a cluster. In each cluster you have a collector which identifies which images are running in that cluster. Then that is pushed to a GitHub repository, a Git repository, and then the orchestrator picks it up and runs multiple scans, for example, the dependency check to identify known vulnerabilities and also other self-made checks. And then they are getting uploaded to DefectDojo. DefectDojo identifies these are the findings which got handled already, and these are the findings which are unhandled, and the unhandled findings are getting sent to the developers or operations people. DefectDojo has a lot of enterprise features, for example, the API, which is very powerful, where you can connect against and get all the information out to create your own statistics, for example. Then you have an Azure ID authentication. You have the ability to perform authorization on product level. So you can do it very fine, granularly. Then you are able to import Azure ID groups so that you can make use of that very a fine granular authorization system, and you can easily deploy DefectDojo, for example, with Helm. This is the OpenAPI definition. So it's done with Swagger, and here you see that you can browse through all the different possible endpoints you have, for example, or the engagements, and you have a key where you can regenerate the key whenever you feel like. Through the API, I personally use it to generate response statistics per team. So it's important to know, are the teams reacting in the way I want to? For example, the policy might state that critical findings needs to be tackled within a day or two. So you can generate statistics and see if that matches or not, and then maybe adjust the policy or help the teams to actually comply to the policy. Or what I also do is the generation of container image lifetime statistics out of DefectDojo, because I have these information in DefectDojo per team. Yes, now I would like to hand over to Stefan.
Yeah, I will just share my screen. That you see how DefectDojo actually looks like. You should now see my screen with the DefectDojo dashboard.
Yes.
Yeah, great. Yeah, so Timo showed us how data can come into into DefectDojo, but now let's have a look what we can do with the data here. So when we started, we see the dashboard. We have some high-level metrics here on the top, how many engagements we have, how many findings came in the last 7 days, how many have been closed, risk accepted, stuff like this. And on the left, we have the main menu. So we can work in 2 ways, basically, with DefectDojo. We can look at single products. We say we have one product and we want to know about this, how the security status, how much vulnerabilities we have. Or we have the possibility to work on a more holistic view, that we see all the findings that we have in the system. This might be if you are the CISO of a company, you don't care for single projects, but you want to have an overall look at things. You might use more of these things. As a product owner, you might look at certain products, and then you can have list the products. And let's have a look, for example, at the juice shop, the OWASP juice shop that has been checked with OWASP SAP and some other tools. So SAP with how Timo showed us before with secure codebooks that is running in the background on the live environment and pushes data into DefectDojo. So when we come in here, we see some high-level metrics for this product. Now we see we have total 60 findings, 6 of them are critical, and some more data. What else do we have? We have components. If we use software composition analysis like dependency check, yarn audit, other tools, it records the components that are in there, that only the vulnerable components, it's not a asset management tool or stuff like this, but all the components that have vulnerabilities in here or findings. Next, we see metrics, so that we have an overview. We see the 60 findings here, with an outbreak of the severity. And what we see here is the different statuses. We have open findings. None of them are verified at the moment. None of them are risks expected. No false positives. No out of scope. There we see we have a status model that is really important when we assess findings. That we do things only once. So with the deduplication algorithm that Timo showed us before, if a finding comes in, I assess it, say, oh, this is an open, this is a false positive, for example, or I do other things that I will show you in a second. When we see it here, it stays like this. If you do another import the next day, the original decision will still be there. It will not be reopened again. We see the engagement, like different kind of groups of tests. Like here we have a manual audit. engagement where we do some manual things, use SEMGREP and Yawn Audit, or we might have a pen test where we feed the data from, or the automated tests like from a CI/CD environment, like the SAPScan that Timo showed us before. And we have 3 different possibilities basically to get data into DefectDojo. It's push, like secure code box that pushes data into DefectDojo via the API of DefectDojo. We can do things manually. We can, lots of tools produce files, JSON files, XML files, or stuff that we can import into DefectDojo either manually via the user interface or via the API. Again, this is typically how it works in CI/CD environments where you have your scanners running in the night or with every commit, and then you import it automatically, or you can do it via the interface manually. And there are some tools where DefectDojo calls the API of the tool, like SonarQube, to get the data. So we have all kinds of integrations. Yeah. Again, most important are the findings. And when I came into the project, I thought, why is it findings and not vulnerabilities? It's a vulnerability management tool. So where do I find the vulnerabilities? But when stuff comes in from the scanners, we don't know, are these really vulnerabilities or are these just things the scanner found? We have to assess it and we have to deal with it. And this is, I think, what DefectDojo is basically for. So, and this we find in the status model. So we could here, for example, see, these are all our open findings. They are there. Scanners have reported them, and in the moment they are there, we see them here listed. And we can do different things with it now. So first of all, we might have users who are not, or stakeholders who are not users of DefectDojo, like maybe a product owner doesn't have access to the system or the management. So we can have a report, like a nice HTML report that we could print as a PDF and send it to someone. Or if we want to do some other things outside with it, we have CSV or Excel exports of the whole list. We can filter the list, can, for example, say we don't want to see everything, but only the SAPScan tests, and then we apply the filter, and we have a much smaller and more usable list. So then we can go into a vulnerability itself and see lots of data. So we have lots of data. It's a huge data model that's behind a vulnerability, a finding, and it is populated by the scanner. So different scanners have different information, and you will find all the information we can gather sorry, here in the system. So here for the SAPScan, we have title, severity, stuff like this. We have the description, mitigation. We know the connection to the endpoint here, for example. If we go in another finding, coming from Yawn Audit, we see the component, for example. We see this description again. We have a vulnerability ID. We can quickly check on the CVE database to get some more information. Another example would be, find it, something coming from SEMGREP, where we see the location in the file. So SEMGREP is a SAS tool, has found a vulnerability in a snippet, and we can, for example, then go directly to the GitHub project here and see the source code, and then start to assess it. What kind of vulnerability is it? Should we care about it or not? And for so we get a good look of all the information we can get out of a scanner here. And then we can start to work on it as well. For example, let's take something of SAP again and say, for example, we have an HTTP site here. So the SAP scanner has found this is not only or not available via HTTPS site, but it's HTTP, which we don't want to have typically. But for example, here we could say, well, it's not ideal, but we want to do a risk acceptance for the moment. So we say we have to accept it, and because we make a recommendation as the security team, we say, well, it's not perfect. And can you have some text? Say there's an older client which only can do HTTP, so we want to accept it for the moment. And then someone else could say, yes, we really accept it, but it expires like beginning of September. Then we want to reassess the whole thing and save it. And then we will see is now has the status inactive and risk accepted. And if we go, for example, on the metrics page, we'll see we have one inactive. This is the risk accepted finding. And so we can go through our findings, assess them. We can do it one by one, or we could use, say, I have several ones and say, okay, I have assessed these 4. Do a bulk edit, say, well, these are, let us say, out of scope for a reason, and not active again, then they are out of the list. Now here we see 55 are still open, and in metrics we see we have 4 out of scope findings. And so we can assess all our vulnerabilities and then get a really good view all the time about the status of our systems or the status of our whole company, the security status, all of our vulnerabilities, and have the possibilities to report it, to get more metrics out of it, and really work with it. And with the API, have lots of other possibilities to integrate it with other systems. So I think we said we have 20 to 25 minutes. I would be in between that right now. Jenna, are there any questions?
So no questions in the chat at present, but one from me, but how can we find out more about this project? Do you guys have a project page or anything like that?
Yeah, of course we have. Don't you just Google DefectDojo, and then you will find the GitHub link. So it's on GitHub, DefectDojo. There you find all the information, the source code, and links to the documentation as well. For example, there's really good documentation of the whole system, how you use it, how you contribute to it, and other things. And for example, the long list, where is it? Importing, for example, this was
supported reports, I think.
Is it
directly under importing?
Oh yeah. So where you here see the long list of scanners here on the right that we actually support, and it's really long. And there sometimes are problems with the scanners, because what we see is all these scanners, lots of open source products or commercial products, and they change their data from time to time. Then there's a new version 3.0, and now it's a different JSON, and stuff might not always work, or there are new features. But then write a bug report.
You're muted, Stefan.
Sorry. Yeah, you can write a bug report on our issues page, and it will be dealt with. Or if you're brave, you write the patch yourself. This is how I started 1.5 years ago. Didn't do any Python or so, and said, well, I need a scanner, and I build it. I will learn Python now. And the team will help you in every way. And the last thing maybe, so every month we have a release. So there's a lot of releases. So every month, currently it's 2.11 since yesterday, and there's a release the first Tuesday of every month. So it's a very, very well maintained project.
I do love your documentation, I have to say. Kudos. So you do actually have a question that's just come in from Max. What is the best way to deploy and install DefectDojo on an enterprise environment? For example, AWS, ECS, versus run it in an EC2 instance. Where can we find documentation about it?
So I would recommend using Kubernetes, where we have a document. So we support Kubernetes, we support Docker Compose, and there's with DefectDojo manual installation if you just have a machine somewhere running, a Linux server. But I would go for Kubernetes, and you find some documentation about it somewhere. I think it's from the docs, you'll find it, installation. How to do on Kubernetes. So this is what I'm running, for example, in my company.
Awesome. I hope that answers your question, Max. And another one here from Francois Eric. Is there an initiative to standardize tools output?
Yes, there are. So there's the Sarif standard. So there's one standard Sarif that some tools use now for their output. And this helps us, for example, because then we don't have to write a parser for lots of scanners. Maybe in the future we will just support the Sarif output, which is for stuff like SAST tools, or I think SCA. I'm not sure how good it will work for dynamic tools, but the Sarif standard is there. And what we see is the SBOMs, bill of materials that can be enhanced with vulnerabilities that come as well. So, as an input partially supported by DefectDojo at the moment. I think they are supported. I haven't used them.
Amazing. I think we have one more that's struggling to get onto the Q&A. Here it is. Using a setup, for example, with DefectDojo and Secure Codebox, how can or should you prevent an application or container with critical vulnerabilities from being deployed to production via CI/CD?
Tricky question. Do you have an answer, Timo?
The question is if you really want to block, right?
Yeah.
That would be the question. Do you want to block it? So when you newly introduce a vulnerability, yes, in the code by a developer, then you want to block. I understand that. The trouble is that you will slow down the pipeline when you block it, because these dynamic tests take some time depending on the environment which you want to scan. So it can be 5 minutes. I also saw shops where it took a day. That depends on the configuration, how many things you are running. But when it's taking too long, from my point of view, the best is to do it asynchronously, like I have shown with the secure code box. You could go to DefectDojo, check when there is a new engagement with a new test, and then block it in case there is something new coming up. But I would, for secure code box, which is mainly dynamic application security testing, wouldn't block. When you have static application security testing, then that is pretty fast. There I would recommend to block it in case there is something unhandled, because then the developer can directly react to it, and you will have a more clean environment. And the question was, I think, how to do that during the build pipeline. Yeah, you go through to the API. I personally use a DefectDojo client, which I created, which is an image. But you can also, there are different API wrappers you can use, and you choose one, and then you go to DefectDojo and ask for this test, which I just the findings which I just uploaded. Is there something unhandled? And in case there is something unhandled with a severity of high, for example, or critical, in case that is there, you stop the build. Or you
Amazing.
stop
Thank
doing
you
the
so
production.
much. guys, definitely. You had a flood of questions there and a few more that we couldn't actually get to. So if your question hasn't been answered today, feel free to reach out to the guys on Hoover. Thank you so much for joining us, Timo, Stefan. That was awesome. Good luck with the project, and we hope you all have a great day ahead. Take care.